What do we know about uranium? Uranium is the most heavy metal found in Earth. To generate energy, 1 tablet uranium is equal to 1 ton of oil, so uranium used as nuclear fuel at nuclear power plants for many years. Uranium gave rise to nuclear power energy industry and hundreds of nuclear reactors, which this very minute generate electricity. In this video, I will tell not only how way to mine uranium, but I'll show you all the way from prey to falling into a nuclear reactor. Therefore, be sure to watch this to the end. This video will change your mind, one of the most dangerous metals on Earth. For many people, uranium is something turbo radioactive, but it's not really so. To understand what uranium is, know a few facts about him. Substance to natural uranium oxide, known to people since ancient times, used it to make icing, which covered various ceramics for water resistance of dishes and various jewelry. In nature, pure uranium fission exists. He is only component of uranium ore. For the first time, uranium in metal was discovered by a German chemist at the end of the 18th century. The substance was called honor, found in space planet uranium. For a long time, no one suspected radioactive properties of this substance and considered it an ordinary metal, and only in 1840, a chemist from France was able to prove that this material is not metal at all, but uranium oxide, and a year later the same scientists isolated uranium in its pure form, by the way precisely, thanks to uranium. In 1896, Henry Becquerel accidentally discovered rays, which were later named radioactive. Uranium is radioactive element. How strong is its radioactivity? Uranium-238 is considered the longest lived. Its half-life is 4s half a billion years. Teach is him half-life can be said to be it radiates weakly. Its alpha particle does not pass through the skin. There is even a story about a Soviet academician Kirkatov, after working with uranium. I just wiped it handkerchief and radiation sickness. He didn't suffer. So if we talk about its radioactivity, who is uranium itself, has a weak radioactivity, but you can ask how weakly radioactive metal can become the main fuel for NPP, and for this you need to know the latest and the most important discovery is the process of fission of uranium nuclei, which happened just before the start Second World War. It was after this discovery that uranium mining around the world. The essence is as follows: if irradiated the nucleus of the isotope uranium-235 by a neutron, then capturing a free neutron begins to share, and as you understand, this process is accompanied by colossal amount of energy. Discovery of this mechanism is starting point for the use of uranium both in nuclear power and military purposes. More than 99% uranium in nature contained in the form of the isotope uranium-238, which is practically harmless human but has the greatest application. Isotope of uranium-235, which is just the same, less than 1%. Only isotopes, this substance, can cause a chain nuclear reaction. Therefore it is used as fuel in nuclear reactors if we talk about military uranium. Then in Russia has not missed him for 20 years. Soviet Union it was produced in such the number of what now, except for Arabic countries, do not need it. It is clear that Iraq, no one will sell radioactive elements. Therefore now all uranium mining goes only to fuel for nuclear power plants. With production, uranium is still more interesting on Earth. Uranium not so little, it is much more common than silver. The truth is it is more difficult to get it than others metals. The problem is that there are almost no deposits, therefore often have to mine uranium mines deep up to a kilometer or even more. Large reserves of this element have been discovered in Canada, Russia, Kazakhstan, and Australia. But the quality of the deposits themselves is very different. For example, in Russia, from 1 ton of ore is obtained in about 1.5 kilograms of uranium. Per other countries, the ratio may be many. Others heard about the turbo and turbo uranium mines, but at the same time, few people know how to get even ordinary iron. Not to mention uranium. In the Soviet Union, there were legends about how it works in uranium mines, doomed to die criminals, soul redeeming his well before the party and the Soviet people. Moreover, there were rumors that uranium miners in mandatory wearing lead underwear. This is, of course, all exaggerated, but there is still truth in these horror stories. Before start of World War II, uranium mining, Soviet Union didn't care much when it is clear that the United States is ahead the Soviet Union in the development of nuclear weapons in 1943. Soviet geologists were given assignments very quickly: find uranium deposit and organize conditions for its study. First, when searching for uranium deposits, was severe lack of equipment and technical equipment. Miners every day were in landslide hazards, flooding, and constantly receiving huge doses. Radiation. Later began to use dosimeters to measure the degree radiation. Mines with a kilometer depth. There was a high temperature reaching 50 degrees. Pose the greatest danger, not radiation, but dust-containing particles, uranium, and other heavy metals, which can enter the body, lead to serious illness. It was also dangerous to have in the air radioactive gas radon, but at operating ventilation. Its concentration, the minimum out. Of course, everything differently. Uranium deposits are searched for by the aero method, gamma shooting, then conducts reconnaissance drilling, studies the rock, estimate reserves, and select mining technology. And there are 3 ways to recycle uranium ore mining. The first way, open. It is used when uranium ore is close to the surface level, and with open pit mining, digs a huge hole with bulldozers, excavators, load labor, dump trucks, who take it to the processing complex. Second way, underground. It uses when uranium ore is located more than deep, with the underground method, vertical shaft being drilled. Depth mines can reach up to 2 kilometers. The miners gave the battle to the genus, raises uranium ore up on special elevators, and they also carry wine processing complex. This method, very similar to the mining of ordinary coal. The third way to extract uranium is radically different from the first 2, called underground leaching. This method will have 6 wells at the corners, hexagon, through which into uranium ore pumped with sulfuric acid. The center of the hexagon will be another well, and pumped through it to surface solution saturated with saline uranium. However, it is not yet uranium, but only its oxide, getting the same pure uranium complex chain of chemical reactions and transformations. But it's not enough just to highlight pure metal, does not carry uranium by itself in itself of such value, and that it be used in nuclear power plants' energy production. It needs to be enriched. The fact is that natural uranium consists of a mixture of 3 isotopes: is uranium-238, uranium-235, and Cerium-234. As we already understood, for nuclear energy is suitable only for uranium-235. But unfortunately, its natural concentration is not enough for stable operation modern nuclear power plant reactor. Although how much? I know the RBMK reactor, as in Chernobyl nuclear power plant, is designed so that it can run on natural fuel uranium, but here is stability and security. Operation on such fuel is not guaranteed, so to use uranium, and with it is necessary to enrich. That is, it is necessary to increase concentration of uranium-235 from the natural date you need for work in the reactor, and uranium-238, it's just heavy gray metal, can be made from an artillery shell or keychain for keys. And here we come to the key, the question of how to separate uranium-238 from uranium-235. The very beginning of the nuclear race as a Soviet Union, and in the USA the idea was master diffusion separation. That is, to pass uranium through a sieve. The calculation was on something that is small, 235, but it will slip through thick, 238, get stuck, and make sieve on the holes. For the Soviet industry in the 46th year was not the most difficult task, and began to build factories, and not just factories, but entire cities, and electricity. These diffusion factories demanded so much that they had to build near a separate power plant. And now imagine 2000 yourself, hefty installations for some 100-gram uranium-235 in our time. Uranium enrichment methods, many, and each of them we disassemble. Of course we won't. I'll just say now, more often uranium enrichment is produced using centrifuge or ranged centrifuge. Very simple and looks like a washing machine in spin mode, only here gas is supplied inside along with molecules. Uranium gas, due to centrifugal force, begins to separate into heavy and light fraction. This mixture falls next centrifuge, and so on until the concentration, 205 uranium, will not reach the desired value. After reaching the required uranium-235 concentrations, and special tablets are pressed from it and created with lubricants, which are removed during firing. Ovens at the same time in another workshop prepares a special tube for fuel elements. That is, at this stage, the creation fuel assemblies with pellets made of uranium-235, and these assemblies are already being built in the nuclear reactor itself. Looks like this SOR-BM reactor cover, under which vertical position is fuel assemblies. 1 square is 1 assembly. Doesn't difficult to write in the comments how much assemblies contains this reactor, so way uranium takes part in electricity generation process. But the story doesn't end there. It would be nice if the pills in early did not decompose into other elements in the process of a nuclear reaction. When work is going on, the reactors are weakening, and the chain reaction stops by itself. It can only be resumed after replacement of uranium in the core. All that accumulated tubes need to be unloaded from the reactor and bury or recycle for reuse. Use of uranium, which worked out in nuclear reactor, is called a regional scientist, or UHARI, in what attack and heat assembly with spent nuclear fuel in USA, Canada, or for example in Sweden. Spent nuclear fuel sent for recycling, just buried like nuclear waste in Russia, is working on a closed fuel cycle. This process allows you to use part of the spent nuclear fuel, creation of new fuel assemblies for nuclear reactors. It is logical that with such an approach themselves waste will stay much less. Why spend money for storage of nuclear waste? On the contrary, you can force bypasses again. Work in a reactor for these purposes is special institutions that engaged in technology and regeneration. Spent nuclear fuel, separating radioactive manure into useful elements using manipulator operators, manage special equipment, hot chambers from high operators. Radioactivity separates only meter-thick lead glass. Just think about the cost of this glass, comparable to the cost of an apartment in a large Russian city, and the whole camera estimated at almost 100 million rubles. Under the action of glass, radiation gradually lose their transparency, and they need a replacement. And all this in order to get valuable from nuclear waste material that can be used for creation of new fuel assemblies for thus the same damage that once mined in the mines enriched up to the desired concentration and then pulled out of reactor as waste is again sent to furnaces where it becomes a uranium pellet. By the way, does the name tell you something? Polonium-210, this chemical element, is considered perfect. I'll give it toxic cyanides 250,000 times. So polonium-210 is possible. Extract from uranium is now full produced only in nuclear reactors and used for various purposes, for example, for making batteries. Spacecraft worldwide per year about 100 grams of polonium is produced. Main manufacturer Russia. Only think about it. The cost of 1 gram of polonium is $4 million. With such prices for Russian chemicals have long been should become the richest country in world, but for some reason it doesn't happen. Scientists predict around 2030 all major uranium deposits, after which will begin development of hard to reach layers, and the price will rise. What will happen next? Big question. Already now continuously there is a tough fight for control mines and deposits of uranium. This the strategic question is the one who holds in hands not only holds sources of uranium by the throat of the entire world nuclear energy, but it can also influence the nuclear market weapons. I think we figured out the history of the discovery uranium and how uranium is involved in nuclear energy. That's all. Subscribe to the channel and write your comments on this video.